Namaskar, my dear friends. Let us design C2000 series microcontroller system circuit design. So what we are going to consider is we are going to consider F280039 CSPZ device or CPZQ1 device or CPZRQ1 device. So these two are same device. They are just tape and reel. Okay. So this will be 100 pin LQFP package. Okay. LQFP package, and the best part is this is the like a real time microcontroller can be used for various application in EV chargers or motor drivers or solar inverters, or name a tool where there is a motor requirement and real time application requirement, even power, like electronics and all. This particular device is one of the most important that we have seen for past 5-6 years. Okay. So the thing that we are going to quickly observe is this is the complete block diagram that we will be talking about around this particular microcontroller, like power supply, safety and protection, then how power supply management works, like different voltage rails, let's say 5 volt or 3.3 volt or some voltage reference like 3 volt, VREF. Okay, so all these things will be a part of power management. Then we have various peripherals like we have connected one potentiometer for ADCs. We have PWMs for motor driver applications, like 12 PWMs can be used for two different motor drivers. We have ADC measurement for different voltage rails and even sensors and all other applications. We have CAN transceiver edge communication. We have LIN transceiver communication. We have sensors like humidity sensor, temperature sensor on the board. We have audio buzzer for alarm beep purpose or something like that. Then we have DAC output also for driving some DAC application. We have EEPROM memory for data storage or something like that using I2C communication interface. We have external interface for daughter board card or something like that, so that you don't have to redesign the microcontroller board each and every time. We have various peripherals like deep switch connections, push button connection, LEDs for user inputs and user output indications. We have USB to UART bridge that is there by silicon devices or silicon labs. So this is basically used for sending your microcontroller microcontroller data to your PC. Then we have JTAG programming and microcontroller reset. Then we have SCI and UART interface communications for various other utilizations. And we have SPI interface as well. So two SPIs are there in this particular microcontroller. Both of them have been utilized. All right. So let's get back to the complete circuit design, as well as we will introduce you quickly how to map the pins in CCS, so that like Code Composer Studio, so that you don't make any mistake in pin arrangement or pin assignment. Okay. All right. So let's get into the circuit. So as we can see, we have this particular microcontroller circuit design, and we can see this is the a symbol that has been made. So let me make it little bigger so that you can see it very clearly. So left side is GPIOs arranged in a increasing fashion. Then we have a few GPIOs on the right side as well. Then these are the analog pins only, like ADC pins, that is ADC A, B and C. Three ADCs are there in this. We have DAC output pin here. Then we have programming pin here. All these 5 programming pins are there, like TMS, TCK, TDI, TDO and reset signal. We have power supply pin that is upward and power supply ground pin that is bottom side. Okay. Coming back to the pin peripheral. So pin peripheral connection, you can see we have PWM connection here. We have crystal oscillator connection here. We have SPI B. So SPI B, MISO, MOSI will be there here. MOSI is here. Then we have ST clock. Similar to that, we have SCIA communication, LIN communication. Then we have CAN communication. So CAN TX, CAN RX is there. We have I2C communication like I2C SCL. This is here, and I2C SDA, it is here. Similar to that, we have deep switches, push buttons and LEDs that is connected like this. One more SPIA was there, which is SPIA A, that MOSI, MISO, CLK and STE pin. And one lean wake up pin is there, that is going to wake up or put it in sleep mode for the lean transceiver to save power. Similar to that, we have analog pins, like we have DAC output here, DAC A1, DAC B1, and then we have temperature sensor and humidity sensor. We have potentiometer, we have voltage monitoring. Coming back to the current sense amplifier, so current sense monitoring for your, like current sense resistors of motor driver, U phase, V phase, W phase. Similar to that, we have voltage, for over temperature sensing on the IPMs, and this is fault signal that is there. So complete package is there for this particular microcontroller. This is the JTAG interface. So JTAG programming interface is there. This is my MCU reset pin. So reset push button is there. So this is how XRSN is connected. We have various requirements of decoupling capacitor for my power supply. So VDD pin power supply is this one, decoupling capacitor, and then we have VDDI decoupling capacitor is this one, and then VDDA is this capacitors. Similar to that, this particular pin has been grounded so that VDD pin will be taking power from VDDIO internally through internal regulator, and we have VDDA pin that is taking power from VDDA. So these two power supplies are actually filtered properly, okay, through ferrite beads. We have reference requirements. So reference voltage is like generated 3 volt, and that is going to my analog ADC pin. And similar to that, V reference of VDAC also is taken from this particular reference pin. If you want, you can remove that and use internal, like a reference also. That is not a problem. Let's move to the next one. So we have humidity sensor and temperature sensor. So humidity sensor is coming RH, and VT is temperature sensor that is getting into this block. After buffering and filtered, it is going to my ADC. Similar to that, we have USB to UART bridge. So USB to UART bridge, this Silicon Lab device is going to convert my UART signal to USB positive and negative signal, and this is how it is getting connected to my micro USB, like connector. And this is also protected with ESD devices. So this ESD, like protection diodes are there from Worth Electronics. So this is the complete, like design for USB to UART bridge. Moving to the next part, we have various other peripherals, like we have audio buzzer here, then we have EEPROM here through I2C communication. We have temperature sensors at this place. Then we have potentiometer connected at this place. Then we have voltage monitoring through ADC, like 5 volt monitoring and 3.3 volt monitoring through proper voltage division, buffers and filters, and then send it to my ADCs. Next, we have push buttons connected at this place, push button 1, push button 2, and then we have two dip switches also. So right side it will be on and left side it will be open. So open means it will be 0, and right side means it will be, left side it will be on. So these two can be giving you total 4 state 0, 0, 0, 1, 1, 0, 1, 1. So these two pins can be configured based on, like your requirement. We have LEDs connection, LED 0, 1, 2, 3 LEDs are there. That is, like going to indicate some purpose that you want on your board. Similar to that, we have CAN transceiver. So this CAN transceiver is having a voltage level translator from 3.3 volt to 5 volt. And this CAN TX CAN RS signal is getting converted to 5 volt. This 5 volt is signal level is going to go to my CAN transceiver. So this CAN transceiver is going to have output with CAN high and CAN low with proper, like resistor termination and split capacitance. Then we have filter capacitors for each of the lines, and we have ESD protection as well. This particular connector is having power supply along with the CAN high and CAN low signals. Okay. Similar to that, we have lean transceivers. As you can see, we have lean RX, lean TX. We have supply pin. Supply pin is coming here, like 12 volt per supply. Then we have CAN, this lean wake up signal also. This lean wake up signal will go high, then it will get grounded, and this is how it will go into sleep mode. This lean output signal is on lean bus. So this lean bus is configured into commander mode. So you can see it is pulled up through this particular power supply and diode and resistors. This lean bus is filtered and protected and send it to my lean bus connector output, and this connector is having DAC A and DAC B output connection as well. Okay, so this is for the outside world. Coming back to the power supply, so power supply, you can see we have like power supply connection here through adapter jack, or we have a power supply connector as well. After fuse, we have been converting this particular power supply input to 5 volt 2 amperes through this particular switching regulator. This is having one reset signal also, which will be monitoring through this particular LED. So if LED is glowing, 5 volt is appearing. If not glowing, it means this has some fault. Similar to that, we have 3.3 volt conversion through 5 volt. So this particular 5 volt is going to get converted to 3.3 volt 0.5 ampere output. Okay. And this is also being monitored through this particular orange LED that will be monitoring 3.3 volt label. Similar to that, we have a voltage output for V reference. So 5 volt is getting converted to 3 volt voltage reference that can be used for your ADC and DAC. Now let us get into the circuit design that we have done through OrCAD. So this is the particular circuit that you saw just now. So this is our microcontroller page. As you can see, we have like all these pin particularly properly connected. And like if you want, you can assign some pin at this place, and let's say my GPIO 30, okay, or GPIO out 1. So this is how you design the circuit. You design the circuit, okay. Similar to that, other pages, if you want, you can like have a look. Like this is my sensor page. So sensor page is completely this. Then we have IOs that is connected at this particular place. We have discrete signal that is connected here. So like we have audio and all these things just now I explained you. We have CAN communication and LIN communication. Then we have USB to UART like connection. And similar to that, we have power supply connection here. Okay, so this power supply, and this is the block diagram that you can see completely. So the block diagram, it like gives you a complete understanding of how to start with what are the things that is connected. Let us quickly open the software and see how we can map all these pins in our Code Composer Studio. So in Code Composer Studio, you can see this is the particular 100 pin microcontroller that is there. So we have pin number 1 to 25. So each side 25 pins are there, and you can see if you hover, it will tell you like GPIO output. Okay. Then similar to that, user LED 1 or something like that. So each of them has been properly assigned. So how to assign them? So basically what you have to do is in your project, this is the project folder for me. This is the project folder for me. And then in this particular project folder, we have generated source. So generated source you can see here. And then coming back to the system configuration file here, this is my main system configuration file. If you double click, you will get this particular file. In this, we have all the systems like AIO, CLS, CLB, DCC, Flash, GPIO, everything. Come to this GPIO. So in this GPIO, we have total 11 GPIO connected, like user LEDs. Then we have push buttons, a start, a stop button. Then we have dip switches, we have fault signal, and one extra GPIO output just now I showed you. So that one it is. So this is how like I'll just make it little smaller. So this is how you can see, you can configure this input mode, output mode, so that we have been like seeing in our software design, like an understanding. So that is there. Similar to that, we have ADCs. So ADCs, several ADCs were used. So I have used ADC 0, that is ADC A it is using. If ADC 1 you use, then it will be using ADC B. So ADC A, you can see we have various peripherals that is connected. Like you can see we have, like a ADC channel 2 is used. Then 4, 5, 6, 7, 8, like that. All of them are used for various like connections that we saw in the circuit. Okay, so you can see, come to the microcontroller page. So these are the ADC pin that is connected. You can see we have a temperature sensor, ADC voltage, shunts, or all these things are there, right? So these particular things are connected in this each one of the channels. Similar to that, we have DAC output. So you can see DAC1, DAC A1 and DAC B1. So both are there. Along with that, we had EPWM, that is PWM signal 1A, 2A, 3A, 4A. So each one of them are having 1A and 1B will also be there along with that. Okay, so if you come down in the pin peripherals, you will see EPWM A and EPWM B. So you want, you can change the pin number also by selecting some other pin. So based on the circuit we have actually already designed, so I don't want to change it right now. All right, so we have CAN transceiver. So this CAN transceiver is used, one of them was used. Then we have I2C, one of them is used. We have lean, one of them is used. Then we have SCI configuration is also like a serial communication interface. We have one SPI modeled right now, so one SPI has been used for this. So this is how you are going to see each one of them. So if you have any questions, any like doubts regarding the pin mapping, or how to start with circuit design and software development for your applications, you can put down your queries in the comment box and we shall be able to give you answers as soon as possible. So alright guys, hope you have enjoyed this particular understanding of complete system circuit design using C2000 real-time microcontroller. And yes, you reach out to us. We shall be able to help you in your design requirements or your project requirements, even corporate trainings or industrial trainings in hardware designs. You can always connect to us and we will be able to figure out how to proceed. Thank you.